From our former lessons we had discussed before, we already knew that there are some differences between nanoworld and macroworld. In this section, we will discuss it further. The case we will lift up to discuss is about the differences of movement between living organisms in macroworld and in nanoworld. In this section, we will use fish and bacteria as an object. In macroworld, there will be turbulent flow because low viscosity, while in nanoworld, there will be laminar flow because high viscosity. So let's take a look to Reynolds number equation. Since the surface area, or A, between bacteria and fish has a big gap, so it will affect the Reynolds number. In low Reynolds number, friction force will be more dominant. Meanwhile, in high Reynolds number, inertia force will be more dominant. These differences between inertia and friction forces will also affect the way of movement between fish and bacteria. So bacteria cannot apply the same movement as fish does. Bacteria has its way to move using flagella and cilia.
Why do we have to build efficient machine even if we know energy is always conserved? Machines work by exchanging each of any form energy becoming another form. Note this, energy is always conserved, but the order of the energy itself is not conserved. Pay attention to this formula. Delta Fa is the useful work we get from the process, and T times of delta Sa is the waste we still cannot avoid. Efficiency is equal to Fa divided by E. We have to design efficient machine so that the waste is becoming so small. Therefore, the efficiency will be close to B1.
We go to discuss about how do you explain why cells membranes are able to push fluid against a pressure gradient. To talk about it, we refer to the osmotic pressure is a simple example of an entropic force, and it causes water flows into the cell. So, what do we know about entropic force? Entropic force is a negative differential of free energy to the displacement. From the mathematical equation, we can also assert that entropic force is force which is created from decreasing of free energy. The cells decay into disorder evolves an entropic pressure in the cells. It happens because the flow of water from the low into high concentration in the cells. If the osmotic is too big, the cell membrane will shatter and it is avoided by cells. At the same time, the pressure gradient in the cell mimics the diffusion flow. It is a phenomenon of water flow from the high pressure in the cells to lower pressure in the surrounding.
I would like to answer the question number 9. In fact, method of storing energy in cells is chemical based. Instead, what molecular machine does in cells is mechanical based. It rather uses chemical based. Now, let's consider about two subsystems that can share their energies and also their particles each other. Those two subsystems are divided into a small one and a larger one. For the small one, we can consider it like enzyme, and for the larger one, we can consider it as a big system that has two isomers of molecules, named N1 and N2. These species are differed from internal energy only. The molecular machine, like enzyme in this case, sees only differences of their chemical potential. Enzyme doesn't change its state after it converts from one isomer into another isomer, and the rate of these changes depend on each species' chemical potential. In one time, there will be two ways of conversion from type 1 to type 2 and vice versa, but the rate of change will depend on their chemical potential. If the chemical potential of isomer 1 is greater than the value of the chemical potential of isomer 2, so there will be a positive rate of conversion from isomer 1 to isomer 2, and vice versa for the other case. It occurs because there is an entropic force that drives deisomerizations from one type into the another type. But if the value of the chemical potential is the same, so the rate of the conversion in either cases are equal. In this case, we can reach chemical equilibrium condition. So that was the physical explanation of how molecular machines extract useful work for storaging energy method inside cell. That is from the difference of species chemical potential.
How will you as an engineer will apply the knowledge you have gained from this course? To answer this question, we will modify advanced medical imaging from brain, or we can say it as AMI. AMI defined as a tiny robot size similar as bacteria because of its tiny size. When AMI in a bloodstream, they will feel a low Reynolds number where it's really thick. It's like people swim in honey. So to make a movement, AMI use flagella as locomotor because the reciprocal movement cannot be applied in a low Reynolds number.